Hello, and thank you for joining me in this tutorial. My name is Melinda Gold, and I'm a product manager working for Artel. My educational background is in molecular biology, so it fits in very well with this topic for this tutorial. In my job, I work with customers to ensure we're developing innovative products that work well and meet your needs. So today I'm going to be talking with you about how you can optimize your genomic workflows with PCRMix. And PCRMix is a new product that we've developed and we are adding to our existing line of solutions for the MVS. I put the abstract up here in case anybody wanted to go back and review it. But there are essentially 4 main points on the agenda for this tutorial. Number 1 is to discuss how aqueous solutions vary greatly in pipetting characteristics compared to Pcr Master mix. Number 2, PCRMix is the new product that Artel has developed to mimic the rheological properties of actual master mix for PCR. 3, we'll talk about how PCRMix allows you to verify the volume of the master mix dispensed. And lastly, number 4, how it will decrease the amount of time you spend optimizing your liquid handler by preventing costly pipetting mistakes. In case you're not already familiar with what Artel does, I'll give you a brief introduction to the company. We provide life science labs with the tools and expertise and knowledge, enabling them to achieve their goals for productivity, compliance, and quality. And this relates specifically to liquid handling, which is at the core of most assays, most biological assays. What we do is we make sure the expected volumes that are dispensed should be independent of the device used, whether it's a single channel, a multi-channel, or even an automated liquid handler. And it should also be independent of the location, whether it's in the US, Europe, Asia, anywhere else, whether it's at sea level or in the highest of mountains. Artel's technology can be used for instrument calibration and verification purposes, but there's also a lot more, including liquid class optimization, which is used to correct the volume of each liquid dispensed at every step of your assay. And later on in this discussion, we'll be discussing how to do liquid class optimization and get into what that really is. So before we get into discussing the new product and liquid class optimization, I want to give you a brief introduction to the MVS technology because PCRMix is used with the MVS. So the MVS, the multi-channel verification system, employs a dual dye, dual wavelength, ratiometric absorbance measurements that are used to calculate the actual volumes that are dispensed. The system, the MVS, works alongside your automated liquid handler, which dispenses dyes of known concentrations into well-characterized microplates. The MVS then takes the absorbance readings at 520 and 730 nanometers and applies Beer's law to calculate the actual sample volume dispensed. So here is a graphical example or a typical workflow using the MVS. This is a very brief introduction to the steps, and it's really as simple as this. A red solution of known concentration is dispensed into the wells of the plate. Then a blue sample, which acts as a diluent, is dispensed into the wells. We shake it on the MVS plate shaker, we read it on the MVS plate reader, and out comes a report to provide dispense accuracy and precision with statistics for the entire plate. Up until now, the dyes we have been producing are aqueous-based and DMSO formulations. But it was becoming apparent that life science laboratories specifically needed solutions, no pun intended there, for viscous liquids with varying rheological properties. And one of the most commonly used solutions with a greater viscosity for life science labs is Pcr Master mix. It turns out that the volume of Pcr Master mix dispensed for an assay does actually affect assay variability. So before we get into talking about the new product and liquid class optimization, I'm going to give you a brief overview of how our product evolution for the multi-channel verification system, the MVS, and the solutions associated with it. It was launched in 2004, and when it was launched, it had the ability to measure aqueous solutions. Since at that time, Artel was only producing aqueous-based range solutions. Skip ahead to 2013, when we also started to manufacture DMSO-based solutions. There was a need in the market for that, since DMSO has very different liquid class parameters or rheological properties compared to aqueous. We wanted to give you the opportunity to accurately measure those types of liquids as well. Now in 2021, we are releasing a brand new product to the line of solutions called PCRMix. And in addition to launching this new product, we have been transitioning our entire brand. And one of the changes that we've made has been consolidating our array of verification solutions under one label, one new label, QualAssure. So we used to call them range sample solutions or range solutions, and that described the volume range that the product was associated with. But now we're using the name QualAssure to describe our solutions. We felt that the QualAssure name better described the assurance and accuracy and precision and the reproducible data that customers have come to expect from using Artel technology and our products and services. Ultimately, our goal is to help you retrieve your goals so you can trust your results. But the aqueous and DMSO QualAssure solutions are the same proven formulas that you have depended on, and the value that they bring remains the same. Why would we create solutions that vary from aqueous? The answer is because not all liquids are created equal. There are other variables in your assays that can be addressed to yield the most accurate and consistent results, and those are shown here in this process optimization graphic, which outlines how to fully optimize your assay from all angles. For example, over here, liquid labware qualification. Not all labware is created equally. Reagent qualification. Not all reagents are created equally. Pipette technique training. Not all operators pipette in the same way, which leads to assay variability. Also, mixing and washing assessment can have an effect on your assay. Liquid handler evaluation, but the one that we are going to be focusing on specifically today is liquid class optimization. So why MasterMix? MasterMix itself is a pre-mixed solution used to speed up assay development to begin with. It's the key component of many genomics-based workflows, which are increasingly popular these days. We knew that there was a need to mimic MasterMix because it varies so greatly in pipetting characteristics from aqueous liquids, and of course, even more so compared to DMSO-based liquids, especially because it's a critical dispense step in your PCR and qPCR assays, since the ingredients in the master mix are inherently tricky to dispense. And believe it or not, up until now, there's been no easy way to test master mix dispenses. So what is in PCR master mix that makes it so tricky to dispense? As you probably know, PCR master mix is a concentrated mixture of components needed to perform PCR. Some of those components include water, DNTPs, magnesium chloride, forward and reverse primers designed to target a specific gene of interest. A DNA polymerase can be a variety of a few different types. In addition, Pcr Buffer, which can include any of or more than one of the following, these guys listed here: tris, potassium chloride, EDTA, glycerol, and there are even some that PCR Master Mix manufacturers are including to improve their reaction efficiency, and we don't necessarily know what those ingredients are. But we can test them and see how they pipette or how they dispense. So Master Mix itself was created to reduce the number of pipetting steps and therefore increase the accuracy and precision and decrease the chances of variability. Therefore, when developing PCRMix, we focused on the key components in Master Mix which affect its pipettability. So all of these things are in Master Mix, but we really focused on the ones that we tested and found that affect variability of pipetting. If you're attending this tutorial, I'm sure you're very familiar with how PCR works, and its reaction is dependent on cycling. But it's also dependent on what we add and the reaction components, and I've relisted them here again. In a typical PCR, in a perfect PCR, you'll start with a target gene of interest. Hopefully it's in your sample if you're looking for it. And with every cycle, you double the number of copies of the gene, of the amplicon. So in this example, we're showing 100% reaction efficiency. It copies, it doubles every single time. And by the 35th cycle, you've got 68 billion copies if you started with one copy. In a qPCR, the results of the reaction will look something like this, where each different sample crossed the fluorescence threshold at a different cycle. So here's the fluorescence threshold, and you can see all of these samples are crossing at a different cycle number. So the lower the cycle number indicates the higher the amount of starting material, which sounds simple enough, but did you know that the volumes of the reaction components that are dispensed incorrectly, such as Master Mix, can have an effect on the assay's results, which could potentially lead to false negatives, false positives, even wasted patient sample. A couple of things we are able to find out about Master Mix and the role it plays in PCR is how under-delivery of Master Mix can significantly impact CQ values. And falsely high CQ values could mean improper gene quantification, which could further translate into misdiagnosing a patient. For example, if the sample doesn't amplify as quickly as it should, it won't cross the fluorescence threshold when it's expected. And then it may seem as though there is less starting material than there actually was. And depending on the sensitivity of your qPCR instrument, your detecting thermocycler, it could potentially even go undetected, meaning you wouldn't know that the sample was there at all to begin with. I'll give you a real-life example of why it's important to dispense the correct volumes of Master Mix and how it can impact your results. So in this example, that looks probably all too familiar to every one of us right now, after a sample is collected from a patient, the RNA is extracted, reverse transcription takes place, changing RNA to cDNA. Then the DNA is quantified, and then the DNA goes off to a PCR. The reaction always requires a specific volume in order for it to occur correctly. These components are typically put into a tube or a plate and then sent off to the thermocycler for the reaction to take place. And I've listed some of the basic components of what I showed you in more detail on some earlier slides. Now you may be asking yourself why the correct delivery volume is essential and what does it really mean? So we'll go deeper into the example and implications of that example. So in this example, PCR was carried out with the correct volumes of Master Mix, which led to a positive diagnosis. which then led to being able to expediently treat the patient, quarantine the patient if needed, and prevent the spread of any particular disease. That's the goal. Now in this example, where under-delivery of master mix occurred, with the same patient sample, a negative diagnosis was reflected, which could lead to a delayed treatment of an infectious disease, which is never good. But a false negative could also mean that the patient is unaware of the diagnosis and can potentially go about spreading a disease. Like I said earlier, this is what Artel does. We create and maintain global standards for liquid handling performance, making sure the correct volume is dispensed no matter where you are, no matter what instrument you're using, from manual to fully automated systems, wherever you are on Earth. And now, with the addition of PCRMix to the portfolio of QualAssure solutions, you can ensure the correct volume is dispensed for your PCR Master mix as well. And how you'll use the solution in a liquid class optimization to do so. That's what I'm going to be getting into now. So liquid class optimization can be used on an automated liquid handler to increase the accuracy and precision of liquid transfers and decrease the variability of results and prevent false results, whether it be false negatives, false positives, or even inconclusive results that lead to wasted patient sample. So in addition to calibration and verification, Artel can also help with liquid class optimization. In this graphic here, I display what you might call your dream automated liquid handler. It has the ability to adjust any type of liquid class setting you could think of, including aspiration speed, dispensing speed, the length of the pause after aspiration or dispense, the blowout, the depth and aspiration, the depth of the aspiration and dispense, the ability to free jet or touch dispense, and some automated liquid handlers even have the ability to adjust an offset. And that can be quite handy. So we know that different liquids have different solutions, or should I say resolutions or tweaks for increasing accuracy and precision. Different liquids bring about different problems, different challenges, is really what they are. And it becomes a challenge for liquid handling when multiple physical properties of these listed here are involved, are at play, are present in your liquid. So in the world of manual pipetting, experienced and trained pipette operators will be able to adjust their technique without even thinking. They do things like slowing down their pipetting speed, pausing, even pre-wetting their tips. And they make adjustments like that, and they often do it on the fly based on experience. However, when using an automated liquid handler, or when the assay is transferred to an automated system, those adjustments need to be explicitly programmed into the liquid handler to ensure accurate and precise liquid handling. So these adjustments are implemented by changing specific liquid class settings and articulating them within the language of the specific liquid handler that you are using. One thing that's really important, and I think I've said this already, to realize is that not all liquid handlers, automated liquid handlers, are created equally, just like not all pipettes are created equally. And different ALHs will have different capabilities. All of these can do something slightly different. Some of them have a lot of the same capabilities, but many of them have capabilities that the others don't. So we as biologists and chemists, scientists, need to realize the capability of the automated liquid handler we're using and use those features in order to provide the best results. The reason we perform liquid class optimization is because we want to make sure the automated liquid handler is actually dispensing the amount, the actual amount, the volume that it is supposed to be. Most automated liquid handling manufacturers have predefined liquid class settings for specific liquids. But most labs will find that they measure their dispensed that when they do measure their dispensed volumes with those predefined liquid classes, they will still need to tweak the liquid class to ensure the correct volume is dispensed. This should be done before an assay is actually carried out with a biological sample, since we wouldn't want to play around with precious patient sample. So we do it before the biological sample enters into the mix. When we know we are dispensing the correct volumes, that's what liquid class optimization is all about. So in this before and after example of dispensing an aqueous solution, we started with a predetermined or a preset setting for aqueous solutions, an aqueous liquid class. And the data is clear that even using this aqueous liquid class with aqueous solution, that when we optimize and make a few changes into that predefined setting, the volumes dispensed are more accurate and more precise compared to the non-optimized image before. Here where my orange lines represent failed values that are out of specification, out of the tolerances. And here, after liquid class optimization on the aqueous liquid class, we have been able to pass and meet within the sustained tolerances. As I already mentioned, the volume of PCR master mix can have a direct effect on PCR results, and the accuracy of qPCR is dependent on the master mix performance and the volume added. And I had also mentioned under delivery of master mix can lead to unexpected CQ values, and falsely high CQ values translate to improper gene quantification in the sample by producing false low concentrations. That can be a problem. And in this image here on the right, this exemplifies how all liquids are not created equal, and they don't perform equally under matched conditions. So what we did here in this example is we've optimized an automated liquid handler to dispense PCRMix, and then we use those same settings to dispense aqueous solution. And as you can see, the results are quite different, which when you think about it is to be expected since, like I said, they have very different properties. This is why we developed PCRMix. PCRMix are solutions for MVS that have been manufactured with a proprietary formulation that includes some of the main constituents that comprise commercial master mix. We chose the ones that have the greatest effect on pipetting variability. So PCRMix was built to mimic the rheological properties of various commercial master mixes, which allow you to verify the volume of the master mix that you've dispensed. And here on the left, you can see a comparison of how our new PCRMix product compares to dispensing of actual commercial master mixes. And if we remember what it looked like on the previous slide, the difference between how PCRMix compares to dispensing to aqueous solutions, very different. So the reason we created this product to mimic the rheological properties of commercial master mix is to allow you to verify the actual volumes of master mix that is dispensed by your automated liquid handler before you add the biological sample into the mix. Regular aqueous solutions are just too different to be used for regular optimization of master mix liquid classes. PCRMix can save you money by decreasing the amount of time you spend optimizing your liquid or your liquid handler and preventing costly pipetting mistakes. The new PCR Master Mix is now another tool in Artel's toolbox, allowing you to quickly optimize your liquid classes for tricky pipetting of PCR Master Mix, especially at small volumes, which happen to be the volumes that people are dispensing master mix at. So therefore, when developing our master mixes, we wanted to do it in the volume ranges that people were using for master mix, which typically tend to span between 2 and 49.99 microliters. So the same volume range, like I said, that master mix is typically dispensed. This is the ordering information in case you want to jot it down. But of course, you can contact me with any questions, whether they be technical in nature or even about ordering. You can see we have 2 different solutions, C and B, to cover those different ranges. So thank you very much for your attention. I appreciate your time. And feel free to email me at mgold@artel.co.